Chapter 19 Practical Electricity.
This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from us.
Use of electricity. The household electrical appliances that we use daily convert electrical energy into other useful energy. Examples are light bulb changes electrical energy to solar energy and thermal energy. Electric fan changes electrical energy to kinetic energy. Water heater changes electrical energy to thermal energy. Speaker or radio changes electrical energy to sound energy. Resistance of a conductor produces heat, which is waste energy. Hence, we use conductors that have low resistance to reduce energy waste. For example, copper wire. Let's learn how to calculate electrical energy and power. Recall the definition of potential difference and current. Potential difference is energy needed to move one unit of charge across 2 points, and the current is the rate of charge per unit time. Hence, if we multiply potential difference and current together, VI will be equals E over Q times Q over T, which will give us energy over time. Therefore, energy E equals VIT. According to Ohm's law, V equals to IR. Therefore, E equals to IR times IT, which will give us I squared RT. Similarly, I equals to V over R. We can substitute the I and the equation becomes E equals to V bracket V over R T. Hence, we'll get energy equals to V squared over RT. Therefore, energy E can be equals to VIT or equals to I squared RT or equals to V squared over RT. Now, let's look at the definition of power. Power is the rate of electrical energy conversion. Therefore, the formula of power is P equals to E over T. By substituting the formula of E, power P can becomes VI or I squared R or V squared over R. So this is the formula of power. Since only passive components or components that consume energy in a circuit have resistance, therefore P equals to I squared R or V squared over R is dissipated power formula. On the other hand, P equals VI is the formula usually used to calculate input power by active components or components that provide energy in a circuit. The SI unit for power is watt, symbol W. SI unit for energy is joules, symbol J. However, kilowatt hour, symbol kWh, is more commonly used, especially in calculating electricity costs. Sometimes 1 kilowatt hour is also called 1 unit. Now, let's look at this example. An air conditioner is rated at 1500 watts. If it is used 8 hours a day for 30 days, calculate the cost of electrical usage of the air conditioner for 30 days. Assume 1 unit of electricity costs 25 cents. B. The total energy used in joules. C. If the voltage supply is 240 volts, calculate the current flowing through the air conditioner when it is turned on. You can pause the video and try to answer the questions yourself. Now, let's look at the solution. For A, the formula is energy equals PT. So, the power is 1.5 kilowatts times 8 hours a day times 30 days. We can get 360 kilowatt hours or 360 units. Therefore, the cost of electricity is equals 360 units times 25 cents per unit, and we get $90. For B, so we already calculated the energy is 360 kilowatt hour. We need to convert it into joules. So we can take the value 360 kilo times 60 minutes times 60 seconds, which will give us 1.296 times 10 to the power of 9 joules, or about 1.3 times 10 to the power of 9 joules, which is to the nearest to 3 significant figure. For C, power equals VI, and I is P over V. The power is 1500 watts over 240 volts, and we get 6.25 amps. Do you get the answer correctly? Dangers of electricity. There are two main types of dangers caused by electricity. The first one is fire. Usually, it is caused by overheating of cables or by ignition of electric sparks on flammable substances. Second danger is electric shock. Usually, it is caused by accidental touch on exposed wires or due to damp conditions. Dangers of electricity due to damaged insulators. Wires and cables are usually insulated so that the conductors that carry electric current are not exposed. However, the layer of insulation can be damaged due to wear and tear. Live wires can be exposed due to damaged insulators. Electric shock may happen if we touch the live wires accidentally. This picture shows damaged insulator, and we can see that the conductor is exposed. So if we touch the conductor accidentally, we might get electric shock. Danger of electricity due to overloaded sockets. If there are too many plugs connected to one socket, the socket will be overloaded and draws large amount of current. Large amount of current will overheat the cables and has the danger of causing fire. So this picture shows one socket is overloaded with a lot of plugs, which we should prevent this to happen. Danger of electricity due to damp conditions. Electrolytes in water is an electrical conductor. If we handle electrical cables, plugs and appliances with wet hands or in damp conditions, the electric current can travel through the water and hence we can experience electric shock. This picture shows where we should install our socket. We should not install our socket near to the ground in the toilet because usually the condition near the ground is wet. So we have the tendency to get electric shock. Dangers of electricity due to short circuits. Excessive flow of electric current can cause danger. Short circuit can cause electric current larger than intended flowing in the circuit. Short circuit provides a path with much lower resistance than intended for electric current to flow. So this circuit is a normal circuit. The current is flowing out from the positive terminal of the battery, passes through the light bulb causing it to light up, and then the current flows back to the negative terminal of the battery. However, if short circuit happens, it provides alternative path with much lower resistance. Hence, the current flows out from the positive terminal of the battery and choose the short circuit and avoid flowing into the lamp and flow back to the negative terminal of the battery. So the light bulb will not shine. The voltage supply to home is set at 240 volts. From Ohm's law, the current I is calculated by I equals to 240 over R. Small amount of resistance R will give large amount of current I. When cables or wire carry the amount of current more than what they are designed to carry, they will become very hot. The rate of heat generated P can be calculated by formula P equals to I squared R. From this formula, large amount of heat generated causes overheating of wires and cables. Overheating can melt insulators and have a risk of getting electric shock. Heat generated can burn the insulation and cause fire. Safe use of electricity. Ring design in home electric circuit. So this diagram will show how ring design works. We start from supply cable. So the blue wire is neutral wire and the red wire is the live wire. So the live wire is connected to the main circuit breaker before flowing into electricity meter. Then they are connected to the main switch, and the live wire is connected to a 30 amps circuit breaker. So this is the circuit breaker box that we can see at home. Then the live wire is connected to live wire ring, and the neutral wire is connected to neutral wire ring. And we have also the earth wire ring, which is connected to the ground. Then we have a socket. The live point will be connected to the live wire ring. The neutral point will be connected to the neutral wire ring. And the earth point will be connected to the earth wire ring. So we can connect as many power sockets as we want. And you can see that all of them are connected in parallel. To supply current to home appliances, two main rings are needed: the live wire ring and the neutral wire ring. In certain countries like Singapore and Malaysia, there is third ring, which is the earth wire ring. The live wire ring is set at 240 volts and the neutral wire ring is set at 0 volts. Without an appliance plugged in, every point on the live wire ring is at 240 volts, while every point on the neutral wire ring is at 0 volts. When an appliance is plugged in, it has physical contact between the live and neutral wire ring and closes the circuit. This produces a potential difference between the two ends of the appliance, allowing current to flow through it. The earth wiring provides a low resistance connection to the ground to prevent users from getting electric shock. Safe use of electricity fuse. A fuse is a safety device that protects a circuit from excessive current flow. When the excessive current flows through the fuse, it will melt or blow and break the circuit. The fuse is always connected to the live wire. It is because excessive current will blow the fuse first before flowing into the appliance connected to the circuit. Hence, the appliance is protected from getting damaged by the excessive current. So let's look at this diagram. This is electric kettle. There are two wires, the live wire and the neutral wire. The fuse is connected at the live wire. So the current flows in through the live wire and it will blow up the fuse first before entering the electric kettle if the current is too much. Hence, this electric kettle is protected from damage of the excessive current. Current rating of a fuse is the minimum amount of current that will blow the fuse. A fuse with current rating slightly higher than the normal working current is chosen to be used in a circuit. Example, 2 amps fuse is used for a circuit that has 1 amp current flowing in it under normal situation. Common fuses available in the market are 1 amps, 2 amps, 5 amps, 10 amps, and 13 amps. Safe use of electricity using circuit breaker. A circuit breaker has similar function as fuse. It trips when it detects a fault in the circuit. A blown fuse needs to be replaced. However, a circuit breaker only needs to be reset after it is tripped. There are three main types of circuit breakers. The first one is miniature circuit breaker or MCB. It trips and disconnects the main electricity supply to a house automatically when it detects excessive current flow by tripping or breaking the circuit. Second type is earth leakage circuit breaker, ELCB. It trips and disconnects main electricity supply when it detects current flowing in the earth circuit. When there is current in the earth wire, it indicates current leakage from live wires. The third circuit breaker is residual current detector, RCD. It trips and disconnects the main electricity supply when it detects a difference in the amount of current between live and neutral wires. This indicates there is a current leakage. Now, let's look at the physical look of circuit breakers. So, I believe that you see this at home. So, you see that there's one row of switches in the electric box. So, this row of switches are usually MCB. And you see that one device here, right, with a large switch. And usually this switch is ELCB. Sometimes you will see RCD as well in the electric box. Safe use of electricity by earthing. Earthing connects the metal parts, or usually metal casing, of an electrical appliance to the earth circuit. When there is a fault, current from live wire leaks to the metal casing. When it is earthed, the current will flow to the ground or earth through the earth circuit. This can prevent electric shock if someone touches the faulty appliance. Now we look at this diagram again. Live wire and north wire is connected to the electric kettle, and we connect a fuse at the live wire. We also earth the metal casing of this electric kettle. If this is a faulty appliance, the current flow to the metal casing. The excess current will flow to the ground. Hence, it will be safe if someone accidentally touched the faulty appliance. Safe use of electricity using double insulation. In double insulation, the live wire of an electrical appliance is coated with 2 layers of insulation. These kind of appliances usually have non-metallic casings. The live wire is insulated to prevent current from leaking into the internal components of the appliance. The internal components of the appliance is also insulated to prevent current from leaking into the external casing. Double insulation usually replaces earth wire. Hence, these appliances use 2-pin plugs. 2-pin plugs provide connection to live and neutral wires only. This is the symbol for double insulation. And you can see the symbol here and here. Safe use of electricity with 3-pin plug. So this diagram shows the physical connection of the 3-pin plug. So the brown colored wire is the live wire. Sometimes it is red color. This is the fuse. This blue or sometimes black wire is the neutral wire. And this green and yellow stripes wire is the earth wire. You need to remember the color of the wire.
That's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write down in the comments. I would love to hear from you. Do you like this video? Please don't forget to like it and share it. Alternatively, you can also enroll this full revision course at Udemy. At Udemy, you can track your learning more effectively. Download my notes in printable PDF form. Take a summative quiz at the end of each chapter. Get your first-hand updated contents from me. Get quicker response from me, and many more. You can get all these benefits at a very affordable price. It is one-time payment, no recurring fees, no hidden costs. This saves you thousands of dollars on expensive tuition fees and revision crash courses. And most importantly, your precious time. Finally, you can do your revision anytime you like, anywhere you prefer. All is available within your fingertips. Check out the description below this video and click on the enrollment link to register the course at discounted price. Alright, until then, see you in the next video. Have a great day ahead.